Hello, this is Mike. You may be wondering why I'm doing this video. Well, let me show you. What is going on in back of me? In back of me, over there, is a super conducting magnet, and I'm filling the outer shell of the magnet with liquid nitrogen right here. The process is pretty simple. You hook up a metal hose to the instrument, and then you have to have a exhaust through which the nitrogen gas can vent out after dumping the liquid nitrogen into the outer door. These superconducting magnets are the predecessor to MRI instruments. This is nuclear magnetic resonance spectroscopy. There are two dewars in that shell of the superconducting magnet. The inner dewar holds the magnet coil, which is kept at liquid helium temperatures. Liquid helium boils at 4 Kelvin, whereas the outer dewar acts as a buffer so that you don't get rapid boil off of your liquid helium, and that serves as a buffer in between the atmospheric room temperature and the 4 Kelvin, the temperature at boiling of liquid helium. Each week we have to fill this up, the magnet, and that means we open the door because liquid nitrogen goes to gaseous nitrogen and will displace air. So let's walk over here. See the tube frosting up. Nitrogen is at a minus 169 degrees C. You can see now I'm filling it up right here, and the blow off is coming out right here. I just wanted to give you a brief introduction. Again, this is preventative maintenance for instrumentation at California State University in Northridge. Have a good day. Bye.